Here we're asked to solve this equation by factoring. So first what we need to do is write this in standard form, and it already is in standard form, which just means all the numbers are on one side and it's set equal to 0. Now we're going to factor. When we're factoring, we're just trying to change this into a multiplication problem. You want to first look to see if there happens to be a greatest common factor of the two terms. And in this case, we're looking for a number that we can divide x squared by, that we can also divide 5x by. And we can divide them both by x, because x squared divided by x is just x, 5x divided by x is 5. So we've changed it into a multiplication problem. You can always check it by just multiplying. X times x is x squared, x times 5 is 5x. So once you have that factored, in this case we can't factor this anymore. X plus 5, we can't change that into something times something equals x plus 5. So we're done factoring. Now we're just going to use the zero product property to come up with the solutions. So in this case we have x times x plus 5 equals 0. Whenever you have a number times another number and the answer is 0, that means that one of those has to be 0. So either x equals 0 or x plus 5 equals 0. And then you just solve these two equations. So the first one's already solved. The second one, we see the answer is -5. So those are our two solutions. If we were to graph this, that means that the parabola crosses the x-axis at 0 and at -5. So it'll look something like this. You can always check your answers by graphing it or by substituting your solutions back into the original equations. So if we have x squared plus 5x equals 0, if we substitute 0 in, we can see that the answer here is 0. 0 plus 0 equals 0. So that one checks out. Or if we substitute in -5, we're going to get -5 squared plus 5 times -5 equals 0. And that works out as well, because that's 25 minus 25 equals 0. So that just confirms to us that our two solutions are 0 and -5.